Okay, Whynauts, I'm super excited because today's episode is...
Out of this world! We're talking about space.
Space!
Como pueden ver, estamos emocionados, pues el episodio de hoy es sobre el espacio. But today, we're all about science, not science fiction.
Space is about what's out there.
Whoa, how'd you do that? ¿Cómo lo haces?
You might even say space is the final frontier. With all this space, we have some room for some very big words.
Well, the words aren't necessarily big words, but they're big like that. Space is full of galaxies, planets, stars, the whole universe.
Sí, el espacio está lleno de galaxias, estrellas, planetas y todo el universo.
The universe is pretty simple to describe because it's basically everything.
Yeah, it's simple, but it's also incredibly complex and amazing.
But before we talk about what's out there, antes de hablar sobre todo el universo, necesitamos hablar de algo. We need to talk about this.
Light swords? Do we need them to save the galaxy from the evil emperor?
No, Joey. Remember, science, not sci-fi. We need to talk about gravity. Gravedad. See, on Earth, we're familiar with gravity because, well, it explains why things fall when you drop them.
But in space, gravity helps us understand why stars, planets, and galaxies behave the way they do. En el espacio, la gravedad nos ayuda a entender por qué las estrellas, los planetas y las galaxias se comportan como lo hacen.
Gravity is a force of attraction that pulls matter together.
Sí, la gravedad es una fuerza de atracción que atrae a la materia.
Next, we have to talk about matter, materia. Matter refers to any substance that has mass and takes up space. It's basically all the stuff that makes up the universe.
Mass, o masa, is the amount of matter something is made of. Anything that has mass also has gravity.
La masa es la cantidad de materia en algo y lo que tiene masa tiene gravedad.
The more mass an object has, the greater its gravitational force.
Entre más grande la masa, es mayor la fuerza gravitacional.
Stars, like our sun, have a whole bunch of mass, therefore exert a whole bunch of gravity.
In fact, the gravity of the sun is what holds all the planets and other objects in our solar system in its orbit.
An orbit is a curved path that a planet, satellite, or spacecraft travels as it circles an object of greater mass.
The gravity of the sun holds the Earth in orbit, and the gravity of the Earth holds the moon in orbit. La gravedad del Sol mantiene a la Tierra en órbita y la gravedad de la Tierra a la Luna.
And some of the other planets in the solar system hold moons in orbit around them too.
Did somebody say solar system?
Mateo, what's that?
What do you mean? Es nuestro sistema solar.
It's not entirely accurate.
Sure it is. It's got the sun, Mercury, Venus, the Earth. Está todo.
I mean, it's all there, but...
It's not exactly to scale. I think we need a Whynauts-style solar system model. We can still use this. You'll see.
Come on, guys, vámonos. Let's head back to the Pro Museum. How'd you do that finger snap thing?
It's all in the wrist.
Whoa! All right, that was science fiction, but that was also very cool.
Our solar system is a very, very big place. So we need some room to demonstrate the relative sizes of our sun and the planets and the space between them.
Okay, so we're gonna start, of course, with the star, la estrella of our show, the sun, el sol.
The sun is a star. Stars are balls of glowing gas and plasma, composed of mostly hydrogen and helium.
Nuestro sol es una estrella y las estrellas están hechas de gas y plasma incandescentes compuestas principalmente de hidrógeno y helio.
So today, for the star of our Whynauts solar system model, we're going to use, why not, the entire Perot Museum. The Perot Museum is about 170 feet tall, so that'll dictate our relative size for scale in our solar system.
The sun is massive. It holds about 99.8% of the solar system's mass. Volume-wise, you can fit 1.3 million Earths inside the sun.
¿Caben 1.3 millones de tierras en el sol? That is big, but as far as stars go, our sun is only a medium-sized yellow dwarf star.
Now let's talk about the relative sizes of the planets in our solar system. Remember this?
My sun seems kinda small.
Well, using the Perot Museum as the size of our sun, this is how big Mercury, the first planet from the sun, would be.
¿Mercurio tendría 7 pulgadas de diámetro?
The next planet from the sun is Venus, or Venus. Venus is larger than Mercury, but compared to our sun, it's about the size of a car tire.
Venus sería del tamaño de una llanta de coche y la Tierra sería del tamaño de una llanta de camioneta. Next up is a planet we're all familiar with, Earth. Earth is only a little bigger than Venus, so using our scale model, it's about the size of a truck tire.
Since we're talking about Earth, we should probably mention our moon. A moon is a natural object that travels around a bigger natural object. Planets, dwarf planets, even asteroids can all have moons.
La Luna es un satélite natural que gira alrededor de un objeto más grande. Nuestra Luna gira alrededor de la Tierra.
Astronomers usually call them satellites or natural satellites. Of course, there are man-made satellites orbiting the Earth too.
The diameter of the moon is about 1/4 the diameter of the Earth, so compared to this truck tire which represents Earth, our moon is about 1 cantaloupe. La Luna sería del tamaño de un melón. ¿Y Marte?
Next planet, Mars. Mars is smaller than Earth, so to scale, it'd be about the size of a small pizza.
Una pizza chica? Oigan, cantaloupe, pizza. This model is making me hungry. But the next planet is a biggie. It's Jupiter, which is the biggest planet in our solar system.
Jupiter's diameter is 11 times the size of Earth's. So on our scale, it's about the size of a giraffe.
Júpiter es 11 veces más grande que la Tierra. Bien grande, so big, but still small compared to our Perot Museum-sized sun.
Next planet on our solar system model is Saturn. Saturn, no. To scale, Saturn would be about the size of a small car.
Saturno sería del tamaño de un coche. Uranus, you're next. For our scale, you're about 1 bicycle wide and tall. Urano es como una bicicleta.
The last planet in our solar system is Neptune. Compared to our Perot Museum-sized sun, which is 170 feet tall, Neptune is about 6 feet. Emma, how tall are you?
5'3", why?
Close enough.
Y Neptuno es un poquito más grande que Emma.
Not funny, guys!
This scale helps us understand the relative size of our planets, but to understand the distance between them, we're gonna need a lot more room.
We're gonna need the Why Not copter.
Can I try snapping this time?
Go for it.
Hey!
Ay, perdón. I think it's time for a quick brain break. Al regresar, trataremos de entender la distancia relativa entre los planetas. When we come back, we're going to travel as far as we need in our Whynauts copter to demonstrate the relative distances between the planets.
Yay, more flying!
We'll be right back to save the princess.
No.
To learn more about space.
Okay, Whynauts, we're back and we're above the Perot Museum, which as you can remember is what we're using to determine our scale. Recuerden que estamos usando el tamaño del museo para determinar la escala.
So now we need to determine how far each planet is from the museum. I mean, sun.
Mercury is an average distance of 36 million miles from the sun, but in our scale model, it's only 1.3 miles away. That means every mile we go in our model represents about 27 million miles out in space. Cada milla representa unos 27 millones de millas en el espacio.
And that puts us here, above the Dallas Farmers Market.
Love that place. They have fresh produce and goods from local farmers 7 days a week. I bet I could find a good moon there. I mean, cantaloupe.
Let's keep going. Next up on our solar system model is Venus. Venus is about 67 million miles from the sun, but for our model, it's about 2.5 miles from the museum. That should put us right above Fair Park. Venus estaría en Fair Park. That's the home of the Texas State Fair.
Now I'm hungry for a corn dog.
Next on our solar system model is our planet, Earth. Earth is 93 million miles away from the sun, but on our model, it's about 3.5 miles. And that puts us above the Dallas Zoo.
Aquí estaría la Tierra.
Lions, tigers, otters, and meerkats.
They have so many great animals there.
Would love to stop and see them all, but next stop, Mars.
Mars is about 142 million miles from the sun, but for our model, that's 5 miles from the museum. Hey, that's White Rock Lake down there.
Órale, Marte estaría en White Rock Lake.
My family goes biking there all the time.
I totally want to take sailing lessons there.
Okay, so we've covered the distance of Mercury, Venus, Earth, and Mars. Those are considered the inner planets, los planetas interiores. Next, on to the gas giants, Jupiter and Saturn.
But first, in this space after Mars, you'll find what is known as the asteroid belt. There, you'd find an incredible number of big and small asteroids, ice, and dust.
Asteroids are rocks that can range from several feet to hundreds of miles across.
Pasando el cinturón de asteroides está Júpiter. Past the asteroid belt is Jupiter. Using our scale model, it's about 18 miles away from our sun at the Perot Museum. We're right next to the DFW airport, al lado del aeropuerto, así que cuidado.
DFW is one of the largest and busiest airports in the world, so we should keep moving.
Next on our model is Saturn Saturno. That takes us 33 miles from the Perot Museum. Check it out, it's the Motor Speedway.
Uranus, you're next, 66 miles away.
Hang on, Whynauts.
On our scale, to get to Uranus, we have to almost leave Texas. That's Lake Texoma down there.
And now for Neptune. We go almost 50 more miles. Remember, every mile that we travel in our model represents about 27 million miles out in space.
So that's our Whynauts-sized solar system model, from the sun at the Perot Museum to Neptune here in Ardmore, Oklahoma. We'll be right back.
Now that was a solar system model.
You two were right. That was way better than the one I brought in earlier. Our solar system is really big. Nuestro sistema solar es realmente grande.
It is, but our solar system is just one of thousands of planetary systems we've confirmed in the universe.
Y es solo uno de muchos sistemas.
I think we should head to the Whynauts Discovery screen to help illustrate how big of a space really is.
Our solar system is just a small part of our galaxy, the Milky Way.
Nuestro sistema solar es solo una parte pequeña de nuestra galaxia, la Vía Láctea.
A galaxy is a collection of billions of stars held together by gravity.
Una galaxia es una colección de billones de estrellas unidas por la gravedad.
Scientists estimate that there's billions, maybe even trillions of galaxies in our universe.
We have discovered thousands of planets beyond our solar system, and there are probably many, many more. We call these exoplanets. Los planetas más allá de nuestro sistema solar son llamados exoplanetas.
But out of all those planets, only a small percentage are in an area that's considered habitable, meaning they may be able to sustain life.
These are planets that exist in what we call the Goldilocks zone.
Not too cold, no muy caliente.
No muy frío, not too hot.
These are planets where conditions for life are just right.
Just right for liquid water to exist. Water is a necessary ingredient for life as we know it.
En ellos podría haber agua y otros elementos necesarios para vivir.
The other requirements are an energy source and the right chemicals, such as carbon, hydrogen, oxygen, and nitrogen.
Carbono, hidrógeno, oxígeno y nitrógeno.
So far, we only know of life on Earth, but scientists are constantly searching for life elsewhere in the universe.
Recently, the Perseverance rover landed on Mars to look for signs of past life.
Who knows? Los científicos siguen buscando planetas habitables. Perhaps they'll have found evidence by the time you're watching this.
I hope so. We don't only send rovers to space, we also send people. Welcome our guest, astronaut Mike Foreman.
Hey, thanks, Joey, Emma, Mateo. It's great to be here.
Thank you so much for joining us, astronaut Mike. ¿Cuál es tu parte favorita de ser un astronauta? What's your favorite part about being an astronaut?
Well, of course, my favorite part of being an astronaut is going to space. But my second favorite part of being an astronaut is getting to come back and talk to people like you all about it.
What made you want to go to space?
I always wanted to be an astronaut since I was 8 years old, and I grew up in the state of Ohio, where I don't know if you know this, there were more astronauts in the US from Ohio than any other state.
Oh.
That is mostly because we had astronauts John Glenn, Neil Armstrong, and Jim Lovell, who you all know probably as Tom Hanks from that movie Apollo 13. They were all from Ohio. So believe it or not, when I was only 8 years old, the news media, TV, newspapers, they had all kinds of stories about these guys being astronauts. And I thought, that is such a cool job. That's what I want to do. So I set my path to become an astronaut.
What's your favorite planet?
My favorite planet has got to be Earth, right? Because this is our home planet. This is the spaceship that we're traveling through the universe on. I've always loved Earth. From space, it's awesome to be an astronaut and get a chance to look down at the Earth from way up there in space. It's so cool. Of course, we don't have to wear spacesuits here because we have this great atmosphere, that we can breathe and live down here. So Earth is definitely my favorite planet, but eventually I think people's favorite planet is going to become Mars because that's where we're going to go someday. Hopefully I'll be alive to see that, and astronauts eventually will get up there.
Any advice for kids who would want to be an astronaut someday?
Well, I'm not the perfect person to ask that question because it took me 8 times applying to NASA before I was selected to be an astronaut. But I do know that NASA is looking for people with STEM background. That means science, technology, engineering, or math degrees, and somebody that's been successful in a previous career prior to them applying to NASA. So I was a pilot, test pilot, and I was fairly successful in that. And I got NASA to notice me after 8 applications, and they invited me down, and they saw what a great personality I have, I guess, and then they invited me to stay. So that's how you do it.
We really appreciate you coming out here and giving us your time and telling us about your career and about space. We really appreciate you. Thank you.
Thanks for having me today.
Are we all ready for the Whynauts pop quiz? ¿Listos para las preguntas?
Let's do it.
What is the force that governs the motion of our solar system?
¿Cuál es la fuerza que maneja el movimiento de nuestro sistema solar? Gravity, la gravedad.
And what is our sun?
Nuestro Sol es una estrella de tamaño medio y es el centro de nuestro sistema solar.
Our sun is a medium-sized yellow dwarf star. It's also the center of our solar system. Its gravity holds all the planets in orbit around it.
Good answer. Okay. Last question. Is this an accurate model of our solar system?
No, I think we kind of made that point.
We learned a lot today, but even scientists have a lot left to learn about the universe.
So maybe some of you will help us learn more as scientists, engineers, or who knows, you may even be astronauts and walk on Mars.
Okay, so I know we're all about science and not science fiction, but since this episode was all about space, can we do a sci-fi movie ending just for fun?
Let's do it, why not?